Okay, so I'm going to explain the physical principles of northern lights. My name is Kai Kawasaki Ueda, and this is the second project for physics. So first of all, it said northern lights, but I thought it would be like polar lights. So some history is that the Vikings thought the northern lights appeared in the sky were the Bifrost, which is a mythical rainbow bridge between Earth or other dimensions to Asgard, where like the gods lived, like Thor and other gods, like Viking gods, lived there. And some indigenous people of Alaska thought that the lights were were their ancestors dancing in the sky, like visiting and watching from the sky. So there are different polar lights. They are divided in by two kinds, which are different by their places. So Aurora Borealis and Australis. Borealis is from the northern and Australis is southern. Some fact is that Galileo Galilei was the first one to name these lights as Aurora Borealis and Australis, and it is generally known as northern lights because in the north it appears more, or there are places where they appear more than the south, because in the north you have like Canada, Alaska, and all the parts of Europe, but in the south you don't have nothing. You just have the southern pole, so it's just ice. So there's no land to see the the lights. It is commonly known that these lights appear only in the poles, like north or south, but it can be seen anywhere, even in the day. Well, not in the day because of the sunlight. Like the sunlight overtakes the light, but it doesn't mean that it doesn't happen. So same as the stars, you cannot actually see the stars in light, but they do appear there. If there is a solar eclipse, you can see the stars in the day. So these lights could appear also in the southern part. It has seen in Singapore and Honolulu, which is in Hawaii, and these will occur extremely rare, but it is due to the solar flare, like big solar flares and solar wind. These lights are caused by three main components, which are the solar wind, the Earth's magnetic field, and the oxygen and nitrogen in our atmosphere. So first of all, what is a solar wind? Solar winds are plasma matter which is exerted from the sun. The sun is in a high energy state, which is caused which then it causes a fourth state of matter, which is plasma. And these electron and protons packs, which are called the solar wind, are unable to escape the massive gravitational pull due to its high energy compound. So these electrons and protons are really excited and high condensed energy, like packs, and they tend to go like elsewhere in the universe. But as you know, our solar system, the Earth is there, so this solar wind also hits the Earth gravitational field, and these solar winds tends to go from 1 million miles per hour. That speed is really high, and sometimes these solar flares could be really big, which causes the distortion of the magnetic field in the Earth. So what is the magnetic field of the Earth? It is caused by the center, like the magma in the center of the Earth. It is by other materials. It is mostly compounded by molten iron, which is a metal compound in the. So due to this high pressure in the center of the Earth, this iron is always in constant movement, and it is well, molten, which is like liquid. And this iron causes this magnetic field, as you can see in the image. It goes from pole to pole, and it creates, like in the crust, these circles, which are not visible, as you know. And in this picture you can see that they are like symmetric, but in real life they are asymmetric. It is almost like a donut. The left side is smaller and the right side is bigger, like circle or ellipses. They are much more bigger and as a shape of a not circular donut, but like a, well, like a donut. Yeah, so you can see here this video. Yeah, that's how the magnetic field is created, and these yellow lines are the flares, like the plasma, the solar wind, and then it hits the magnetic field of the Earth, and it stretches this this magnetic field. We're gonna see it again. So you can see here how you have this magnetic field of the Earth, and then the solar wind, which in this case is really big, hits the magnetic field, and then it distorts the magnetic field, and this energy and this electron and protons from the plasma goes all the way to the back of the Earth's magnetic field, and then as an elastic band they tend to stretch and then they break. So when they break, these electrons tends to go to the poles, and this highly energized electron and proton, these excited electron and protons, hits the atmosphere's nitrogen and oxygen atoms. So when this highly energy compound element hits the atom, these atoms get excited. So this means that they are not stable, so they have more energy than they should have. And these nitrogen and oxygen atoms tends to exert that energy gained by these electron and protons in form of photons. These photons are what causes these beautiful lights and colors, and they tend to differentiate in color first from what atoms they are exerted, and also the height and other components of the atmosphere in that moment. But in general, oxygen releases green, red, and yellow lights, and the nitrogen exerts blue color. So this combination of red, green, yellow, and blue colors create these amazing and extraordinary beautiful northern lights. So that's it. I'll link well the references in the video. Thank